All right, welcome to the review video for the first part of this chapter involving areas and volumes and arc lengths. So the first part of this is going to be just the first few questions of your review packet for our test on Friday. First question, identify the definite integrals that represents the area of the region bounded by the graphs of y equals 4 minus x squared and y equals x minus 2. And I apologize that those are so small, but you will see these tomorrow. And so we want to find the area of the region bounded by those graphs. And so we have to find out which one is larger and which one is smaller. So you can use a graphing calculator to do this. I'm going to have to just sketch it really quick here so you can see what's going on. This is a parabola that opens downward with a y-intercept of positive 4. So we can go here. I'm going to have to graph the other side as well, it looks like. So it's going to look something like this. And sketching graphs is an important part of what we're doing in this chapter here. So being able to sketch these graphs is important. And x minus 2, that means I have a y-intercept of negative 2, and I have a slope of negative. It's like 1 or positive 1, so 1 over 1 up, 1 over 1 up, etc. So it's going to kind of be down here somewhere. Now, if we go back, we want to know where these two intersect. And the easy way to do that without having to actually follow the graph you can see there is just set them equal to each other and solve. So if I'm going to move everything over to the right side, 0 equals x squared plus x, and it looks like minus 6. That means that the places where they intersect, of course, will be at negative 3 and looks like positive 2. So x is negative 3, and then x is positive 2, so say or. So therefore, my bounds of integration are going to be from negative 3 to about positive 2. All right, so I have part of that set up, negative 3 to positive 2. Let's eliminate any ones that don't have that. It looks like all of these have those. So now I need to determine what is the distance from the top and the bottom to that rectangle, because that's really what I want. I want the area between those curves. And so it's going to be the top function minus the bottom function, like this. 4 minus x squared, that's the top, minus the bottom function, which is x minus 2 dx. Now we're so used to all of this being complicated and having to revolve around an axis, I'm literally just finding the two-dimensional area. So if I distribute here, I get 4 minus x squared minus x plus 2. Now I could look here and sort of simplify that. They roll from negative 3 to 2. It looks like negative x squared minus x plus 6. Anything pop out to you? Should be choice B. Not too shabby. Let's move on to the next question, number 2. Which of the following integrals represents the volume of the solid form by revolving the region bounded by the graphs of y equals x cubed, y equals 8, and x equals 1 about the line x equals 2. So again, this is going to require us to do a little bit of sketching, so I'll do that now. You can see that I've drawn the lines given. X equals 1 is this vertical blue line. That's the left boundary. The top boundary is y equals 8, and the right boundary is this line x equals 2. And technically also the boundary is this x cubed mark. Now, because all of my answers, if you look closely to all of my choices, they have the 2 pi out front, which leads me to believe that I'm using the shell method. And so for shells, the volume is given as follows. The integral from a to b of 2 pi times h of x, which is the height of the rectangle, and times p of x, which is the distance from the axis of rotation, times the width, dx. Okay, so this is 2 pi rh times the depth, essentially. Now we need to define what the rectangle looks like. So I'm going to think about the distance, the top of this rectangle to the bottom. Well, the top of the rectangle is going to be 8. Then I have to subtract down the other height, which is x cubed, 8 minus x cubed. And the distance from the axis of rotation is going to be this x-axis this way. That's going to be 2 minus wherever I am integrating from, so 2 minus x. You can see that if I plug those into this equation here and pull out the 2 pi, I'm going to have 2 pi times the integral, and I'm integrating x values, so I'm going from 1 to 2. And it looks like I have 8 minus x cubed times 2 minus x dx. And that's going to be answer choice D as in dog. Even though that they are in the wrong order, their multiplication is commutative there, so I'm going to go with letter D. Let's go to the next question. Okay, number 3, the base of the solid is the region in the first quadrant bounded by the line x equals 2y plus 6 in the coordinate axes. What is the volume of the solid if every cross-section perpendicular to the y-axis is a square? First, let's sketch the two-dimensional view of this. See, I've included the x and the y-axis labeled there. I've also labeled the boundaries, which had to be the coordinate axes, y equals 0, which is the x-axis, and x equals 0, which is the y-axis. Now, plotting the line x equals negative 2y plus 6, you can do one of two ways. You can solve for y pretty easily. You get x minus 6 divided by negative 2, and that would equal your y. So in other words, you have negative 1/2 x, looks like plus 3. So that's one way to do it. Or you can think of it from the perspective of the x equals. So you know that this would mean that I have an x-intercept of 6 and a slope of negative 2y, which is kind of interesting to think about. But here's what it would look like. I have negative 1/2 as my slope. So it's going to intersect right there. And so I have this triangle. And so my area that's acting as the base of this is right in this triangle here that I'm drawing in sort of that indigo color. And I want every cross-section perpendicular to the y-axis is a square. So now I'm going to sketch it in 3 dimensions so you get a better idea. Now you can see it, I've kind of sketched it down here, and I've tried to color code it as best I can. You can see the y-axis is going sort of left to right, and then the x-axis going, I guess, in the other direction, left to right, up and down. But we want these cross-sections to be perpendicular to the y-axis. So on my rectangle that I'm going to draw is going to be perpendicular to the y-axis here. It's going to turn into this square. So I'm going to try to make this 3-dimensional object here. Probably going to stop there, actually. I'm going to make it as square as I can. And so you can imagine what this is going to look like if I just keep making these cross sections and they kind of go down towards that space here. So that's what my 3-dimensional object is going to look like. And so to find the volume of that shape, we need to integrate the cross-sectional area on the y-axis. And so on the y-axis, I'm traveling from the y values of 0 to 3. And I need to integrate a function in terms of y, dy. And so the area of the square is obviously just the base squared. And this dy is going to be the width of this infinitely small width of that rectangular prism there. So the area of the base, well, it is the base squared. So the base is defined by this line, x equals negative 2y plus 6. So I'm integrating negative 2y plus 6, the base, squared dy. So I can go ahead and integrate that using a calculator or just by hand. And that ends up being about 36 exactly. 36 units to the 3rd power. So looks like answer B is our choice. All right. That should be enough for now. We'll go more over this in class. Have a good evening.